How do internal combustion engines produce greenhouse gas emissions? Imagine a machine that turns fuel into motion, powering almost every vehicle on the road today. That's what an internal combustion engine does. It's a type of heat engine that transforms chemical energy and fuel into mechanical work. Most cars, trucks, and many machines relying on these engines, which burn gasoline or diesel to operate. The process is based on thermodynamics, where heat from fuel is converted into movement through cycles of compression, combustion, expansion, and exhaust. When you fill your vehicle with gasoline or diesel, you're adding a hydrocarbon fuel made mostly of hydrogen and carbon atoms. Inside the engine, this fuel mixes with air and is ignited. The ignition causes a rapid chemical reaction called combustion, which produces heat and gases. The main products are carbon dioxide and water, along with heat that pushes the engine's pistons and makes the vehicle move. Now, here's where greenhouse gases come into play. Carbon dioxide is a greenhouse gas, meaning it traps heat in the Earth's atmosphere. When you burn a gallon of gasoline, about 20 pounds of carbon dioxide are released into the air. This happens because the carbon atoms in the fuel combine with oxygen from the air during combustion, forming carbon dioxide. The more fuel burned, the more carbon dioxide is produced. But carbon dioxide isn't the only greenhouse gas from internal combustion engines. Depending on how the engine is built, how it's used, and the type of fuel, other gases like methane and nitrous oxide can also be released. Methane is a much more potent greenhouse gas than carbon dioxide, and nitrous oxide is even more effective at trapping heat. These gases often form during incomplete combustion or as byproducts of high-temperature reactions between nitrogen and oxygen in the air. Besides greenhouse gases, engines also produce pollutants like carbon monoxide, nitrogen oxides, and tiny particulate matter. While these aren't greenhouse gases, they contribute to air pollution and health problems. But focusing on climate change, it's mainly the carbon dioxide, methane, and nitrous oxide that matter. The process of burning fuel isn't just about what comes out of the tailpipe. The entire life cycle of fuel production, from extraction and refining to transportation, also releases greenhouse gases. This is called the well-to-wheel perspective. The total climate impact of a vehicle includes emissions from all these stages, not just driving. From a thermodynamics point of view, engine efficiency plays a big role. No engine converts all the energy and fuel into useful work. Some energy is always lost as waste heat. The less efficient the engine, the more fuel it needs to go the same distance, and the more greenhouse gases it produces. Modern engines are designed to be more efficient than older models, but they still burn hydrocarbons and emit carbon dioxide. Practical solutions like hybrid vehicles combine an internal combustion engine with an electric motor. This improves efficiency and reduces fuel use and emissions. Fully electric vehicles do not produce tailpipe emissions at all, but the electricity they use may come from power plants that do emit greenhouse gases. To sum it up, internal combustion engines produce greenhouse gases by burning hydrocarbon fuels, which releases carbon dioxide, methane, and nitrous oxide as byproducts. The amount depends on the fuel used, how efficient the engine is, and how the vehicle is driven. Understanding this process shows how thermodynamics principles are involved in everyday machines and their impact on our planet. Recognizing these facts can help us see why improving engine technology and shifting to cleaner transportation options are important steps toward reducing climate change.